Hello everyone, I am Dr. Tokkummaa Geetahuun, and I'm going to explain the second topic. The second one is the major trends in the periodic table. As you can see from this picture, electroaffinity and ionization energy are directly proportional. Atomic radius is inversely proportional to electroaffinity, and it is also inversely proportional to ionization energy. So down the group, atomic radius increases. So these all are major trends in the periodic table. They are also named as periodic properties. So we are going to discuss this one by one. So this is the definition of periodic table trends. It is a regular pattern, or it is a trend observed in the properties of elements. It is also known as periodic properties. I already told you about this. So it helps us to understand the behavior and the characteristics of elements. So these are the major periodic trends. So these are atomic radius, electronegativity, ionization energy, electroaffinity. What is electroaffinity? We will also see this one. And the next one is metallic character and also non-metallic character, etc. So let us begin, okay, by discussing these major trends of periodic table one by one. So this can be explained based on nuclear charge and effective nuclear charge. What is nuclear charge? This is very simple. This is a total positive charge in the nucleus of the atom, or it is also equal to the number of protons. So nuclear charge is equal to number of protons. So it is simply number of protons that is available in the nucleus of the atom. So it is also named as atomic number of the elements. And the second one is effective nuclear charge. Z effect. This is the attractive positive charge of nuclear protons acting on valence electrons. And it can be calculated by using this formula. Z effect is equal to Z minus S. What is Z? This is nuclear charge, the number of protons in the nucleus of the atom. S is inner electron. That shields the valence electron. Okay, so that one is simply inner electron, and it can be designated by using capital S. And all the time, this Z effect is less than Z. Effective nuclear charge is less than nuclear charge or number of proton for the atom. For example, let us calculate the effective nuclear charge for sodium atom. So the nuclear charge for sodium atom is plus 11. This is number of proton in the nucleus of the atom. Minus 10. 10 is what? The inner electron. So for example, we can easily draw the Bohr diagrammatic representation for sodium atom. The total number of electrons for this neutral atom is 11. 11 is the total number of electrons for this atom. And the first shell, so this is nucleus. In the nucleus we have 11 proton and also neutron. For example, the mass of sodium is 23. 23 minus 11. Atomic mass minus number of proton, or atomic number. It gives you the number of neutron for that atom. So 23 minus 11, 12. We have 12 neutron in the nucleus of the atom. The first shell contains only 2 electrons. The second shell can have a maximum of 8 electrons. So totally we have 11 electrons for sodium atom. 1, 2, 3, 4, 5, 6, 7, 8. And the third shell can contain only 1 electron for sodium atom, because totally we have 11 electrons. So this is valence electron, okay? Valence electron. And all these electrons are inner electrons, okay? These are inner electrons. Totally how many inner electrons we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, 11 minus 10. This is equal to positive 1. Plus 1 is the effective nuclear charge for sodium atom. Similarly for magnesium, it is plus 2, because 12 minus 10. 10 is the inner electron for magnesium atom, and 12 is the number of proton. That is nuclear charge for magnesium atom. So plus 12 minus 10 equal to plus 2, and the plus 2 is the effective nuclear charge for magnesium atom. And when we move from left to right across the period, effective nuclear charge increases. This nuclear charge also increases because atomic number increases. Therefore, nuclear charge increases from left to right across the period. Not only that one, down the group from top to bottom, nuclear charge increases, okay? But effective nuclear charge is the same. So S is inner electron, that shell is valence electron. And the fact that the inner electron's shell or screen the outer electrons from the full charge of the nucleus is known as screening effect or shielding effect. Therefore, we can explain these periodic trends or periodic properties based on nuclear charge and effective nuclear charge. Okay, the first periodic property is atomic radius. What is atomic radius? This is really very simple. From your mathematics knowledge, you know about radius. Okay, radius is the distance between the center of the circle up to the curve. Okay, this distance is simply known as r, and from this point to this point it can be named as diameter. In chemistry point of view, atomic radius is defined as the distance between the nucleus and the valence shell of the atom. It can also be defined as, for especially for metals, it is half the distance between the nuclei of the two adjacent atoms. There is an assumption. According to that assumption, metals, okay, one atom of metal touch another atom of metal. Therefore, the distance between the nucleus, half of that distance is equal to the atomic radius for metals. Okay, you can see from this one, for diatomic elements also, radius is equal to half the distance between the nuclei of the atoms. The nuclei of the atom, this is radius, but this one is diameter. For example, this is for chlorine atom. The distance between the nuclei of two atoms of chlorine molecule is equal to 198 picometer. Therefore, the radius of one atom of chlorine is 198 divided by 2, that is equal to 99 picometer. Therefore, radius is equal to distance over 2. So this is atomic radius. Okay, let us come to the trends. Okay, as you move down a group, atomic radius increases. Why? Why atomic radius increases? Because shell increases. Okay, when we move down the group, shell of the atoms increases. When shell increases, the radius of the atoms also increases. Okay, let us see some examples. This is, for example, the atomic radius for group 1A, metals. Okay, lithium to cesium. The shell increases from lithium to cesium. This is on second. This is the period for lithium is 2. The period for sodium is 3. Therefore, the shell increases. As the shell increases, the radius also increases. They are directly proportional. So because of this reason, down the group, atomic radius increases. As you move left to right, across the period, radius decreases. Why? Because the shell is the same for all elements in the same period. However, extra electrons are added on the shell, and those electrons directly attract with the positive charge of the nucleus. Because of this attraction, the atomic radius of these elements decreases across the period from left to right. Effective nuclear charge also increases. Nuclear charge also increases. Therefore, increasing number of valence electrons is being added to the same shell, and this one reduces the radius of these elements. Okay, atomic radius of period 3 elements. Period 3 elements, okay. So sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. So when we move from left to right across the period, the radius, atomic radius decreases. For sodium, it is 1.86 angstrom. Angstrom is nothing but it is equal to 1 times 10 to the power of minus 10 meter. So this one has only 1.60 angstrom of radius, and it decreases when you move from left to right across the period. So this table shows you the atomic radius of period 3 elements. So these elements are group A elements. What about for B group elements? For B group elements, by the way, electrons enter an inner shell. Therefore, the valency shell will not increase. Only the inner shell increases. Electrons will add to the inner shell, not the valency shell. So that defect is the same. Because of this reason, the radius should be almost the same. Let us see example for these B group elements. Let us compare Z effect. Effective nuclear charge for iron, cobalt, and nickel. These are B group elements. So iron has 26 number of proton. So Z effect can be calculated by using plus 26 minus inner electron, that is 24. So it is plus 2. And the atomic number for cobalt is 27. One electron goes to the inner shell, d orbital. Therefore, Z effect is equal to 27 minus 25. It is also equal to plus 2. And the third one, nickel. The atomic number for nickel is 28. So the electron goes to inner shell, D8, okay? Z effect is equal to plus 28 minus 26. So it is also equal to 2. They have the same Z effect. Their atomic radius is also almost the same. 124 picometer, that is for iron, 124 picometer for cobalt, and 125 picometer for nickel. Therefore, for B group elements, their atomic radii should be almost the same. So try to identify this one. What about ionic radius? You are familiar about ions. Ions are positively charged and negatively charged particles. So we can classify ions as cations and anions. Cations are positively charged ions and anions are negatively charged ions. Therefore, cations always smaller than the original atom. For example, Na. This one has greater radius when compared with sodium ion. This is cation, okay? Because we have positive charge on this atom. And due to this can be named as cation, sodium ion, okay? All the time cations are always smaller than the original atom. Why? Because of Z effect. As Z effect increases, so the atomic radius decreases. We already have seen about this one. When an electron is lost, electron-electron repulsion decreases, and therefore shielding effect also decreases. The protons are better able to pull the remaining electrons towards the nucleus and decreases the size of that ion when compared with the neutral atom. Conversely, anions are always larger than the original atom. For example, take this one, Cl minus. It has greater radius when compared with chlorine atom, neutral chlorine atom. Therefore, anions are always larger than original atom. So can you compare the ionic radius for these ions? And also we have neon atom here. All of them are isoelectronic with each other. What is isoelectronic? This is nothing but atoms or ions having the same number of electrons. All of them have the same number of electrons. So all the time Na3 minus has greater radius when compared with that of O2 minus oxide ion, and it has greater radius when compared with fluoride ion. It has greater radius when compared with that of neon, and it has greater radius when compared with that of Na plus, sodium plus, and this has greater radius than magnesium 2 plus, and it has greater than that of aluminum 3 plus. Okay, let me show you how cations are formed. Okay, look at this picture. Okay, in this picture, in the nucleus we have 11 proton. Okay, this is the number of proton for sodium atom, because we have one valency electron in the outermost shell. So this one is for the atom, for the neutral atom. So sodium atom has one valency electron. If this valency electron is lost, what happens? Valence electron lost in ion formation. Okay, therefore this can be removed. This can be removed. At the end, there is attraction between these electrons and the nucleus of the atom. The number of protons is the same, but electrons are reduced. So attraction increases. That reduces the size of this ion, sodium ion. Okay, so effective nuclear charge on remaining electrons increases. Remaining electrons are pulled in closer to the nucleus. Therefore, ionic size decreases. So all the time, okay, cations have smaller radius when compared with their neutral atom. So result, smaller sodium cation, Na plus. Okay, in the case of anion formation, so we have, for example, 7 electrons in the outermost shell for chlorine atom. This is for neutral chlorine atom. We have 17 number of protons in the nucleus of this atom, and totally we have 17 electrons. This is Bohr diagrammatic representation for chlorine atom. So for chloride ion formation, so we have one electron. So if this electron is added, what happens? Chlorine atom with 7 valence electron. For neutral chlorine atom, if it gains electron, one electron is added to the outermost shell. One electron is added as the end. What happens? So after that, it expands, and this electron goes to this shell. Okay, another extra electron is added. So effective nuclear charge is reduced, and the electron cloud expands. That increases the radius of this ion. Therefore, chloride ion is produced, and this one has greater radius when compared with that of the original chlorine atom. So I told you this one, the order of the radii should be N3 minus. It has greater than that of O2 minus, and the radius of this O2 minus is greater than that of F minus. It continues just like that. The second one is ionization energy. What is ionization energy? This is the amount of energy required to remove an electron from gaseous atom. Therefore, it is an amount of energy required, okay, to remove electrons from the outermost shell. Then ions will be formed. We can just represent as, for example, if we have M, okay, in the gaseous atom, adding energy, what will happen? M plus in the gaseous form, and then one electron is removed. Energy is added to remove this electron. So this is simply known as ionization energy. Ionization energy is all the time. It is endothermic process. You know about endothermic and exothermic reactions. In endothermic reaction, energy is absorbed by that reaction from the surrounding. But in the case of exothermic, exo means out, thermic means heat. If heat is released when chemical reaction takes place to the surroundings, therefore that is simply known as exothermic process. So this one is first ionization energy. If the second electron is removed after adding energy, therefore that is simply known as second ionization energy. You can represent as M plus G plus energy. When one electron is removed, M2 plus in the gaseous form plus another electron. So this is second ionization energy. If the third electron is removed from this one, if one electron removed plus energy, then M3 plus electron. This is in the gaseous form. This is third ionization energy. And all the time remember that third ionization energy is greater than second ionization energy, and the second ionization energy is greater than first ionization energy. So let us compare, okay, the ionization energy of some elements of the periodic table. So this is the way you represent this type of chemical reaction. That is simply endothermic process. This is simply for ionization energy. M in the gaseous form plus energy, M plus in the gaseous form plus electron. One electron is removed after adding energy. Therefore, this is ionization energy. Low ionization energy, that means easy to remove the electron. High ionization energy, hard to remove the electron. So as you move down a group, ionization energy decreases. Why? Because shielding effect makes it easier to remove the outermost electrons. So down the group, the shell increases. So it is really very easy to remove the valence electron from elements as we move down the group. So all the time, down the group, ionization energy decreases. See the first ionization energy of alkali metals, okay? Lithium, sodium, potassium, rubidium, cesium. So this is in kilojoule per mole. Lithium 520, so it decreases down the group. So lithium, sodium, potassium, down the group, ionization energy decreases. 1 electron volt is equal to 96.9 kilojoule per mole. You are familiar about this one. But as we move from left to right across the period, ionization energy increases. What is the reason? Why ionization energy increases? Because nuclear charge increases and the decrease in atomic radius. Because atomic radius decreases. So there is high attraction between the valence electron and the nucleus of that atom. So it is really very hard to remove the electrons as we move from left to right across the period. So valence electrons are tightly held by the nucleus. But there are some factors that affect ionization energy of atoms. I'll tell you this one later, but look at the ionization energy of these elements. First, ionization energy for lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So this one, beryllium, has high ionization energy when compared with boron. Why? I told you that when we move from left to right across the period, ionization energy increases. Why? The ionization energy of this boron is not greater than that of beryllium because of stability of this beryllium. Beryllium has 4 number of electrons. So we can write the electron configuration for beryllium as 1s2, 2s2. So s orbital, it has only 1 orbital, and 1 orbital can have a maximum of 2 electrons. So this is fulfilled. So it is very difficult to remove electron from this one when compared with that of boron. But in boron, we have also another electron in p orbital, p1, okay, 1 orbital. But p has 3 orbitals, so less energy is required to remove this electron when compared with that of beryllium. In a similar manner, when you compare the ionization energy of nitrogen and oxygen, when you write the electron configuration for nitrogen, it ends at p3. So this is half filled. But oxygen p4. It is easy to remove electron from oxygen when compared with that of nitrogen. This is the reason. I will tell you the factors that affect us ionization energy on next slide, but all the time remember that noble gases have the highest ionization energy of all because they are in the most stable. They are inert elements. They are stable elements when compared with other elements. So from stable elements, it is really difficult to remove electrons when compared with other elements. I told you that third ionization energy is greater than second ionization energy. So second ionization energy is greater than first ionization energy. Okay, so these are the factors. First one is atomic size. As atomic size increases, so what happens to the ionization energy? Less energy is required to remove electron. So ionization energy decreases. As atomic size of the elements increases, so it is really very easy to remove electrons. So valence electrons are less tightly held by the nucleus because they are very far from the nucleus. So attraction decreases. Because of this reason, less energy is required to remove electrons. So ionization energy decreases. The second factor is Z effect, effective nuclear charge. The smaller the effect, the lower energy needed to remove electron. So they are directly proportional. As Z effect decreases, ionization energy also decreases. So Z effect is also another factor that affects ionization energy. The third one is type of electron. So you are familiar about this one. S orbital is closer to the nucleus. So attraction increases, okay? So when we move from F orbital to S orbital, F is very far from the nucleus, so it is easy to remove electron from F orbital when compared with that of D orbital, and easy to remove electron from D orbital than P orbital, and it is easy to remove electron from P orbital than S orbital. So the closer an electron is to the nucleus, the more difficult it is to remove the electron. Hence ionization energy decreases in the order of S, P, D, F. And the fourth one is screening effect by inner electron. Screening decreases ionization energy. So less energy is required to remove from such type of atoms which has high screening effect. So screening effect is also another factor that affects ionization energy. And the last one is stability. I told you about this one. So you can also compare the ionization energy of these elements based on their stability, based on their electron configuration. So beryllium S2, okay, this is the last electron configuration for beryllium, but for boron P1. So it requires less energy to remove electron from boron when compared with that of beryllium. So N ends at P3, that is half filled, but oxygen P4, less energy is required to remove electron from oxygen when compared with that of nitrogen. So these are factors that affect ionization energy of the elements. The next one is electroaffinity. This is the energy released when electron is added on the atom. The process is opposite to that of ionization energy. So this is represented by this general equation. The energy released when electron is added, for example, X in the gaseous form. When electron is added, so X minus in the gaseous form plus energy is released. So this process is exothermic process. The energy released when electron is added is simply known as electroaffinity. So you can also represent by this general equation. Okay, so I told you about this one. So this is really very simple. X in the gaseous form, when electron is added, energy is released. So this is electroaffinity. So the process is opposite to that of ionization energy. I already told you about ionization energy. As you move down a group, electroaffinity decreases. Okay, so electroaffinity decreases down the group. This is directly proportional to that of ionization energy. And as we move from left to right across the period, electroaffinity increases. What is the reason? Because atomic radius and the nuclear charge increases when we move down the group from top to bottom. But here, I want to tell you one thing. Down the group, fluorine, okay, let us compare the electroaffinity for these elements, halogen family elements. Fluorine, chlorine, bromine, iodine. I told you that when we move down the group from top to bottom, electroaffinity decreases. So, according to this general trend, fluorine must have high electroaffinity. But here, you should know that chlorine has high electroaffinity when compared with that of fluorine. What is the reason? Because of the size of fluorine. Fluorine has smaller size. Due to this reason, chlorine has high electroaffinity when compared with that of fluorine. Bromine has less electroaffinity when compared with that of chlorine, and iodine has less electroaffinity than bromine, because down the group electroaffinity decreases. This is the reason. Okay, so look at the electroaffinities of these elements. Okay, for halogen family elements, the electroaffinity of fluorine is 328. Okay, chlorine 349. This is higher than the electroaffinity of fluorine, because fluorine has smaller size when compared with that of chlorine. I already told you about this one. So all the time try to remember that chlorine has higher electroaffinity than fluorine. But as you move from left to right across the period, electroaffinity increases. This is due to an increase in the effective nuclear charge. The elements show greater attraction for an extra added electron. For example, from left to right across the period, okay, electroaffinity increases. But here nitrogen has zero electroaffinity. Beryllium has also zero affinity. Why? Because this one has stable electron configuration. Nitrogen, okay, this one half filled. I already told you about this one. So it does not require extra electron. But from left to right across the period, electroaffinity increases. This abnormal trend of electroaffinity can be explained on the basis of electron configuration. I already told you about this one. So nitrogen has half filled, but beryllium has full filled. Because of this one, they do not require extra electron. Therefore, they have smaller electroaffinity. Another one is electronegativity. Another periodic property is electronegativity. This is nothing but the ability of an atom to attract electrons to itself in a compound. So this is the definition of electronegativity. The higher electronegativity, the more the atom is able to attract electrons to itself. An atom with high ionization energy and electron affinity also tends to have high electronegativity. So they are directly proportional. So down the group, electronegativity decreases. Electroaffinity also decreases. Ionization energy also decreases. But from left to right, across the period, this one, electronegativity increases. Electroaffinity also increases. Ionization energy also increases. The reason is that atomic radius increases. If atomic radius increases, so the attraction between the valence electrons and the nucleus decreases, because the valence electrons are very far from the nucleus. Therefore, so they do not require extra electrons. That's why electronegativity decreases down the group. Okay, let us see. Okay, this is an example. The most electronegative element is fluorine. Its electronegativity value is 4. Okay, So chlorine has 3.0 electronegativity value, bromine 2.8, iodine 2.5. So down the group, electronegativity decreases all the time. Remember this one. Okay, as you move from left to right across the period, I told you that electronegativity increases. Why? Because atomic radius decreases. If atomic radius decreases, the attraction between the valence electrons and the nucleus, because of the presence of proton, increases. So because of this reason, all the time, remember that as you move, as you go from left to right across the period, electronegativity of the elements increases. Okay, let us see. Okay, an example. So sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. From left to right, electronegativity increases. Okay, the electronegativity of sodium is 0.9 and the electronegativity of chlorine is 3.0. So the electronegativity increases from left to right across the period. All of them are in the same period. Okay, another one is metallic character. This is the tendency of the metals to lose electrons to form positive ions. Because of this reason, they are also named as electropositive elements. But in the case of non-metallic character, non-metals have the tendency to gain electrons to form negative ions. They are also named as electronegative atoms. So as we move down the group from top to bottom, metallic character increases. But from left to right, across the period, metallic character decreases. Because on the right hand side of the periodic table, there are non-metals, but on the left hand side of the periodic table, we have metals, but in the intermediate, we have metalloids. Therefore, metallic character increases down the group, but decreases from left to right across the period. Why? Because atomic radius increases. So elements easily lose electrons when the shell increases because the attraction decreases. Okay, so becomes easier for elements to lose their valence electron and form positive ions when their atomic radius increases because the attraction decreases. As you move from left to right across the period, I told you that metallic character decreases. Okay, so atomic radius decreases. This is the reason. Okay, let us see an example. Okay, for some elements, sodium. Okay, on the left hand side of the periodic table, but argon is on the right hand side of the periodic table. So as you move from left to right across the period, metallic character decreases. You just go to the non-metals in the right hand side of the periodic table. At the intermediate, we have metalloids. Silicon is metalloid. Okay, but sodium is most active metal when compared with that of magnesium, and the magnesium is more reactive when compared with that of aluminum. So this one tells you that this metallic character decreases from left to right across the period. So this is a summary of trends. So these are periodic properties. Nuclear charge, it increases down the group from top to bottom, and it also increases from left to right across the period. The second periodic property is atomic radius. I already told you about this one. It increases down the group but decreases from left to right across the period. Ionization energy decreases down the group from top to bottom, so they are inversely proportional. So but increases from left to right across the period. Okay, and the next periodic property is electroaffinity. It decreases down the group. It is directly proportional to ionization energy. It increases from left to right across the period. Electronegativity decreases down the group but increases from left to right across the period, directly proportional to electroaffinity and ionization energy. Valence, this is constant down the group, but when you move from left to right, it increases. You are familiar about this one. And another one is metallic character. So it increases down the group but decreases from left to right across the period. Non-metallic character and the metallic character are inversely proportional. Down the group, non-metallic character decreases, but from left to right across the period, non-metallic character increases. You have non-metals in the right hand side of the periodic table, but you have metals on the left hand side of the periodic table. So now let us answer some questions, and these questions, some of them are from university entrance exam questions. So let us see, okay, together. The first question says that which of the following elements has the lowest ionization energy? I told you that down the group, ionization energy decreases. Okay, so now these alkali metals, sodium, okay, so lithium, sodium, potassium, rubidium, cesium, francium, down the group ionization energy decreases. So this question says that which of the following elements has the lowest ionization energy? Cesium has lowest ionization energy when compared with that of potassium, sodium, and rubidium, because down the group ionization energy decreases. So C is the correct answer for question number 1. Question number 2. Question number 2 says which one of the following element has the highest electroaffinity? I already told you about this one. Down the group electroaffinity decreases, but because of the small size of fluorine, chlorine has larger electroaffinity when compared with that of fluorine. Therefore B is the correct answer. Okay, all the time remember this one, don't be confused. Okay, I already told you about this one. So this is the factor that affects electroaffinity of elements. Because of the small size of fluorine, it has smaller electroaffinity than chlorine. So B is the correct answer. Question number 3. Which of the following is the correct increasing order of atomic radius for the elements? These elements are on the same period. So, for example, sodium, then magnesium, okay? Next to sodium, magnesium. Magnesium is second group element, 2A group element. Then aluminum, then silicon, then phosphorus, argon, okay? So, this question says that which of the following is the correct increasing order of atomic radius? Atomic radius decreases from left to right across the period. Therefore, argon has a smaller size, a smaller radius when compared with other elements of the same period. Therefore, from this one, first argon, it has a smaller atomic radius, and then the next one is what? Silicon. Silicon is here. So then silicon, then aluminum, then as the end sodium. Sodium has larger radius when compared with other elements of the same period, because from left to right across the period atomic size decreases. Therefore the correct answer is argon, silicon, aluminum, sodium. So it increases from argon to sodium. C is the correct answer for this question. Okay, question number 4. Which of the following properties increases down the group in the modern periodic classification of the elements? I already told you that electroaffinity decreases down the group from top to bottom, but increases from left to right across the period. Ionization energy decreases down the group from top to bottom, but increases from left to right across the period. Electronegativity also decreases down the group from top to bottom, but increases from left to right across the period. But this question says that which of the following properties increases down the group in the modern periodic classification of the elements? Down the group, metallic character increases, but from left to right, metallic character decreases. So D is the correct answer for this question. Okay, another question, question number 5. Which one of the following elements is most electronegative? Fluorine is the most electronegative element. Okay, its electronegativity value is 4.0. So B is the correct answer. Question number 6. It says ionization energy can be affected by A, atomic size, B, effective nuclear charge, C, types of electron, D, all. All of them affect the ionization energy of the elements. So I already told you that screening effect also affects ionization energy of the elements, and another one is electron configuration. Stability also affects ionization energy. So D is the correct answer for this question. Question number 7. The energy released when an electron is added to an isolated neutral atom is called electroaffinity. I already told you about this one. If electron is added and if energy is released, this is electroaffinity. So electroaffinity is the correct answer for question number 7. A is the answer. Question number 8. Which one of the following element has the highest ionization energy? I already told you that ionization energy increases from left to right across the period. But because of the stability of this nitrogen atom, I already told you that nitrogen has larger ionization energy when compared with oxygen. So C is the correct answer. Don't forget this one. 9th one. Across the period, atomic radius of the elements, across the period from left to right, atomic radius decreases. So B is the correct answer. Question number 10. Which one of the following increases both down a group and across a period in the periodic table? I already told you this one. Nuclear charge. Nuclear charge increases down the group and also increases from left to right across the period. So D is the correct answer. Which of the following elements has the largest atomic radius? Atomic radius, okay? These are elements of the same period. So I told you that from left to right across the period, atomic radius decreases. So sodium is in group 1 A element. So it has higher atomic radius when compared with other elements of the same period. So A is the correct answer. Question number 12. Which of the following is the most metallic elements among the following? Down the group, metallic character increases. So calcium is the most metallic element when compared with other elements. But silicon is not metal. It is a metalloid. Which of the following has the smallest radius? I already told you that anions have higher radius when compared with their neutral atoms. But cations have smaller radius when compared with their neutral atoms. So D is the correct answer. Mg2+. If you have Al3+ in the choice, so that is the correct answer. But now we have no aluminum ion, Al3+, but we have magnesium 2+. As the positive charge increases, the radius decreases. So D is the correct answer. So this is all about the periodic trends of the periodic table. Thank you for watching. Thank you for listening. Bye bye.